Hello everyone, I'm Neeraj Kumar from CSCB section. In Applied Physics, today we're going to discuss about quantum computers. In quantum computers, we're going to discuss briefly about introduction and history, basic concept of quantum computer, applications, advantages, disadvantages and problem, and future work, that means future help, future scope of quantum computers. Introduction of quantum computers. What does quantum mean? The word quantum in quantum computer originates from quantum mechanics, a basic theory in physics. In brief, on the scale of atoms and molecules, matter behaves in a quantum manner. What is a quantum computer? A quantum computer is a machine that performs calculations based on laws of quantum mechanics, which is the behavior of particles at the subatomic level. History of quantum mechanics. In 1980, Max Planck energy quantum. In 1921, Einstein discovery of photon. In 1980, idea of quantum computation. In 1996, Groves came up with an algorithm to search a name in unsorted database. Grover's algorithm and the law of superpositioning makes this possible. Superpositioning is discussed later in this paper. In December of last year, Anton Zeilinger made a fantastic accomplishment. This feat was achieved using a principle called quantum entanglement. Quantum entanglement is discussed later in this PPT. Basic concept of quantum computers and differences with existing computers. In existing computers, all information is expressed in terms of zeros and ones, and the entity that carries such information is called a bit. A bit can be either a zero or one state in at any one moment in time. A quantum computer, on the other hand, uses a quantum bit, qubit, instead of a bit. A qubit also makes use of two states, 0 and 1, to hold information. But in contrast to the bit, in this state, a qubit can take on the properties of 0 and 1 simultaneously at any one moment. Accordingly, two qubits in the state can express the four values of 0, 0, 0, 1, 1, 0, and 1, all at one time. This slide shows the difference between classical bit and a quantum bit. A qubit is superposition is in both of the states, greater than less than 1, less than 0 at the same time. Classical bit versus qubit. Classical bit is in the range of 0 and 1, but qubits are in the range of 0, 1, superposed states of 0 and 1. Yeah. The figure shows classical bit and quantum bits. This figure shows the sample of a quantum computer. What is different about quantum computers? Application. There is much that is different between quantum computers and classical computers, but I'm going to explain briefly. Quantum superpositioning, quantum entanglement, and quantum teleportation. Now let's discuss about quantum superposition. Superpositioning is a big word for an own concept. The two things can overlap each other without interfering with each other. In classical computers, electrons cannot occupy the same space at the same time, but as waves they can. One may think of this as a vector of the probabilities drawn in a two-dimensional coordinate system of the complex mind. That is, coordinates of the form x plus iy, where x is a coordinate on the real number line and y is a coordinate on imaginary number line. Classical bits are either vectors of 0 or 1 and have no imaginary component. For an equation describing a physical phenomenon, the superposition principle states that a combination of solutions to a linear equation is also a solution. When this is true, the equation is said to obey the superposition principle. For example, consider an electron with two possible configurations up and down. They describe the physical system of a qubit. It is the most general state, but these coefficients dictate probabilities for the system to be in either configuration. The probability for a specified configuration is given by the square of the absolute value of the coefficient. The probabilities must add to 1 since the electron must be in one of these two states, P up C1 square or P2 C2, P down C2 square. P up plus down is equal to 1. Continuing with this example, if a particle can be in state up and down, it can also be in state where it is an amount of 3i by 5 up and amount of 3 by 5 down. Quantum bits or qubits have both components. If the probabilities were equal, the vector could be represented at 45 degrees from vertical. If the probability of 1 but y is that of 0, the vector could be represented as 30 degrees from vertical. This vector represents the superposition of the probability of 1 and the probability of 0 simultaneously. In this way, the state vectors of classical bits are collapsed qubit state vectors. How superposition state working in quantum computers. Superposition of 0 and 1 states. Superposition state. Quantum entanglement. Entanglement is the ability of quantum system to exhibit correlations between states with a superposition. Quantum entanglement is one of the central principles of quantum physics, though it is also highly misunderstood. In short, quantum entanglement means that multiple particles are linked together in a way such that the measurement of one particle's quantum state determines the possible quantum states of the other particles. When this happens, the state of the two particles is said to be entangled. An aura of glamorous mystery attaches to the concept of quantum entanglement and also to the related claim that quantum theory requires many worlds. Yet in the end, those are or should be scientific ideas with down-to-earth meanings and concrete implications. Here, I'd like to explain the concept of entanglement and many worlds as simply and clearly as I know how. Entanglement is often regarded as a uniquely quantum mechanical phenomenon, but is not. In fact, it is enlightening, though somewhat conventional, to consider a simple non-quantum or classic version of entanglement first. This enables us to pry the subtlety of entanglement itself apart from the general oddity of quantum theory. Quantum entanglement. Unlike ordinary bits of information, qubits can be linked in a way that has no analog in the digital. This linkage, called entanglement, acts instantaneously over any distance. Once they have been entangled, they are in an indeterminate state. The qubits can then be separated by any distance, but they will remain linked. When one of the qubits is manipulated, say, to perform a step in the quantum computer program, the manipulation happens instantly to its entangled twin as well. If the manipulation includes reading the state of one of the qubits, the entanglement ends and both qubit states are revealed. Quantum teleportation. Teleportation. Quantum teleportation is a technique used in transfer information on a quantum level, usually from one particle to another. Its distinguishing feature is that it can transmit the information present in a quantum superposition, useful for quantum communication and computation. One of the scientific articles to investigate quantum teleportation is teleporting an unknown quantum state via dual classical and Einstein-Podolsky-Rosen channels. Experimental determinations of quantum teleportation have been made in information content including photons, atoms, electrons, and superconducting circuits, as well as distance with 1400 kilometers being the longest distance of successful teleportation by the group. Jane Weapon using the Mauritius satellite for space-based quantum teleportation. The sources required for quantum teleportation are a communication channel capable of transmitting two classical bits, a means of generating an entangled Bell state of qubits and distributing to two different locations performing a Bell measurement. One of the Bell state qubits and manipulating the quantum state of the other qubit from the tape. Of course, there must be also be some input qubit in the quantum state to be teleported. The protocol is then as follows. Applications of quantum computers. Encryption technology, ultra-secure and super-dense communications, improved error correction and error detection, molecular simulations through randomness, cryptography, searching, factorization, simulating encryption problem, and quantum chemistry problem. Advantages of quantum computers could process massive amount of complex data, ability to solve scientific and commercial problems, process data in a much faster speed, capability to convey more accurate answers, more can be computed in less time. These are used to protect secure web pages, encrypted email, and many other types of data. Disadvantages and problems of quantum computers. Hard to control quantum particles, lots of heat, expensive, difficult to build, not suitable for word processing and email. Problem of it need of a noise-free and cool environment. Complex hardware schemes like superconductors. Feature work. Silicon quantum computer. It may become technology sooner than we expect. At a current rate of chip miniaturization, energy efficiency, and economics, the classical computer of the year 2020, if it could happen at all, would contain a CPU running at 40 GHz or 40,000 MHz with 160 GB RAM and run on 40 watts of power. New algorithms and communication maximum exploitation simulate other quantum systems. This is end of my presentation regarding quantum computers. Hope you gain some knowledge regarding quantum computers. Thank you.